Okay, let's now work one that's a little more challenging here. We're going to use hydrogen, oxygen to produce water, and we're going to do some calculations with those. Actually, we're going to use this equation to do a number of calculations, keeping the equation consistent so that you have a continuity of thought. So here we go. As usual, let's just dissect this. Calculate the amount in grams of water. There's where we're headed. That's our box. Produced from 128 grams of O2. This sounds very much like the previous problem. Only thing is we're starting with grams of water and going to grams of oxygen instead of dealing with moles. So here we go. How many grams of water? I'm going to put grams above, consistent with our little map here. And we're producing 128 grams, or we're using 128 grams of oxygen. So I'm going to put the 128 grams of here. Again, in my mind's eye, what I'm seeing is the stars here. As you can see, it's going to be pretty easy calculation at this point. Yes, using our map, I'm going to go from grams of oxygen to moles of oxygen. Then I'm going to go from moles of oxygen to moles of water, and then I'm going to go from moles of water to grams of water in the last step. Okay, now that I see what we have to do, I'm just going to set up the dimensional analysis and complete the problem. We know that there's a mole that we have to go through. We have to go through the mole hole. We have to go through moles. So this should be in your mind's eye over here. But if it's not, every time you work one of these problems, you can just set it up like this. You write what you're given somewhere. You write a box what you're looking for, and then you go from one to the other. And in this case, of course, it's pretty easy to see that you're going to go from here to here to here to here. Okay, so let's now work that out, and I will show you the answer to that one. Okay, let's walk through it. The box is grams of water, and our star is 128 grams of O2. So here we go. Box equals star, and do the flight path until you get to your answer. So we're going to leave grams of oxygen. We're going to leave grams of oxygen and arrive at moles of oxygen. That's our first step. Then in the second step, see, the first step corresponds to, and let me map this out so you can actually see it. Every path you have, every arrow that you draw on your flight path means a different conversion factor. So you can almost think about these being bridges. As you need a certain toll, you need a certain conversion factor to get you from one point to the other. Okay, back to continuing again. I'm going from grams of O2 to moles of O2. Then I'm going to go from moles of O2 to moles of H2O. Moles of H2O. And then I'm going to go from moles of H2O to grams of H2O. From moles of H2O to grams of H2O. This is what we were looking for with grams of H2O. That's how I know we're done, because the unit on the right now equals the unit on the left exactly. So to see that, grams of O2 crosses off, moles of O2 crosses off, moles of water crosses off. The only unit left is grams of water, and the unit that you're looking for is grams of water. This is the point at which you pick up your calculator. And remember, anything in the numerator in the top, you hit a multiply sign. Anything at the bottom, you hit a divide by sign. So you could punch out 128 divided by 32 times 2 times 18. You'll get 144. Or you could do 128 times 2 times 18 divided by 32. Or any combination. Okay, let's look at another variation of this. We'll move a little quicker this time because hopefully you're getting the hang of it by now. How many grams of hydrogen? Okay, I'm looking for grams of hydrogen. There's hydrogen. I'm going to put my box above H2 to correspond to that. Will react with 128 grams of oxygen. I'm going to put the 128 grams of here, and that corresponds with my given starting point. Okay, very quickly I can see I'm going to go from grams of O2 to moles of O2, moles of O2 to moles of H2, moles of H2 to grams of H2, putting it on our equation. From grams of O2 to moles of O2, from moles of O2 to moles of H2, from moles of H2 to grams of H2. And now let's see what that looks like in terms of a dimensional analysis equation. And here we go. This is our box, grams of H2, and we're starting out at 128 grams of oxygen. I'm going to go from grams of oxygen to moles of oxygen, from moles of oxygen to moles of hydrogen, from moles of hydrogen to grams of hydrogen. Where did I get this? This is called atomic number. I got this from the periodic chart. Where did I get this? I got this from the balanced chemical equation. And where did I get the conversion factor from the last one? As always, gram to moles are gotten from the periodic chart. The answer is 128 times 2 divided by 32 equals 144.